A bead of mass m slide on a semicircular wire of radius small r. The surfaces in contact are smooth. It is slightly pushed. When it is slight, very almost zero, just pushed. Okay, that means velocity zero, initial velocity just slightly, gently pushed. At the highest point, then find the speed of the bead. So they are saying it as what? Tell me now here. So a semicircular wire, right? A semicircular wire is there like this. Having some radius is smaller. Now see what they're saying here. A bead is there at the highest point. Now just imagine now this is gently pushed. Initially that is at rest only. And it is gently pushed. That means what happens now? Very small force, negligible force. Yes. Now gently pushed. Now the bead will start sliding down on this wire. So let us say the bead reaches to here at this point, from here to here. When it is here, now they are asking to find what will be the speed of the bead. So assume that this point we are calling it as A and this point we are calling it as a B. Now this bead reaches to this point B. Right. Now look at now here. Now here the radius, this is O to A, distance is R. Assume that the bead has traveled down. Why the bead is moving down? Because of gravitational force. So here, so this much of height has been formed by the bead now here, this much height h. Right. Now you can see now here O to A is the radius. O to B is also radius only. And this says, so this point, if I call C now, AC is a H. That means how much is OC now here? That is R minus H, and O to B is also R. If I call this angle is something theta, if I call. Now look at now here. So the bead is falling down because of gravitational force. Gravitational force is a conservative force. Can you apply the law of conservation of energy? Yeah, tell me now here from law of conservation of energy, from where to where we are applying here. So A and B. Tell me now here UA plus KA equal to what we can say now, this is UB plus KB and UA. So we have taken, assume that I am taking this as a reference line we have taken. Okay. A highest point we are assuming it as a reference. So here A and B we should take some reference line we should take. I have taken A, I have taken as a reference line. Yeah, tell me now then initially potential energy, how much you tell me now? 0. It is at the reference line only now. So that's why potential energy 0. And kinetic energy initially rest only in a bead. Kinetic energy also 0. Now here this bead finally at the point B, it is moved by a distance of h now. So then potential energy is there now, mgh, positive or negative? Yes, why positive, why negative? So that means what? Tell me now, potential energy case we should take the reference line we need to see. Yes, if it is below reference line, negative, above reference line, positive. The work done is different. And here we are talking about what? Tell me now. Potential energy. Now, potential energy case, the reference line is a crucial point. Whether the body lies below the reference line or above, we need to see. It lies above or below. Below means what I should say? Negative. And it has a kinetic energy na at the point B. It has some velocities there na. That velocity I'm calling it as a VB. That velocity we need to find na. That is how much now? Of m into VB square. Right. So from this we'll get it as what? Tell me now. 1 by 2. Velocity, kinetic energy always positive, remember. Only potential energy can be positive or negative. But kinetic energy always positive. Yes, velocity positive only, na? Velocity, even the velocity negative, square of the value positive only will come. Mass is always positive. So kinetic energy never be negative. And which is equal to what? Tell me now, mgh. M cancel na? So how much the VB value? That is square root of 2gh. And here the thing is h. For the h is the height. Remember in the problem, we need to give the answer na expression. That should be always in the given terms in the problem only. Here h is the we have considered. In the problem not mentioned. For the problem what they mention, you tell me now here r mentioned some angle we have considered. So with then r and theta only we have to express it. So for this, what I should do now, we'll take the triangle of OCB. Yeah, OCB triangle. From OCB triangle, what is the cos theta? Tell me now. Cos theta equal to what? Tell me now. R minus H by R na. So from this cross multiply, this is R cos theta equal to R minus H. H is equal to what we can say now? R common 1 minus cos theta. So this value we need to place now here. That is square root of 2g r into 1 minus cos theta. Theta also we have considered. Theta, okay, actually they will mention the problem expressed in terms of vertical angle.